Here's the guide for factoring polynomials. We need to start with the common monomial factoring. Then whatever will be the result, we're going to categorize them as to whether the result is a binomial, trinomial, or multinomial. And we have specific processes under specific results. Then we end it. Let's start with this polynomial. We have here a trinomial, specifically a quadratic trinomial, because it has three terms, of course, first and foremost. And when you look at the variables, they are arranged, or we have terms in decreasing order of the same variable. We have x squared, we have x, and a constant, which is also known to have x to the power 0, or just simply times 1. So when we factor trinomial like this, there are two possible scenarios. We need to check whether this is a given this given is a perfect square trinomial, because we have a specific or separate factoring for that. And if it's not, we also have a different method for that. So to check, we are going to determine first if this is a perfect square trinomial or not. And we can do that by examining our given. A perfect square trinomial has two different conditions. The first condition is the first term and the third term, or the last term, are perfect square. So our first term is x squared. This is a perfect square of x. Our last term, the constant, is 4. This is a perfect square of 2. So our first condition has been met. Again, the first condition is that the first and the third term must be perfect squares. The second condition is with this criteria. The second term must result to this computation twice the square root of the first term times the square root of the third term. If it meets this criteria, this means that it is really, or the given is really, a perfect square trinomial. If it doesn't meet with this, then it's not a perfect square trinomial, and we proceed with another method. So let's try to look at here. Our second term is negative 4x. Let us see if this is equal to 2 times the square root of the first term. X squared is actually x, times the square root of the third term is 4. And take note, when you take the square root of a constant, you could have two possible results. Plus, minus, the square root of 4 is 2. These are possible because we are, again, have satisfied the first condition that the first and the second terms are perfect square expressions. So don't forget that this is a sign, plus minus. We will not be adding it to here, okay? So then we have here minus 4x. Does it meet the criteria of this? So we have two possible results for our right-hand side. 2 times 2, so you have plus minus 4 times x. And since we have two possible results here, we have shown that our middle term, minus 4x, is one of the two possible values of this process. So you have minus 4x. We have satisfied the second condition. And with this, we are now sure that this is a perfect square trinomial. And the factoring method for a perfect square trinomial is this. A perfect square trinomial is simply a result of a square of a binomial. So the square of a binomial will follow this one here. Look at this. Square root of the first term, x. Square root of the last term, 2. And since there are two possible results, plus, minus, which of the two? Look at the sign of the middle term, minus, so we have minus here. So this is now the factor, or this 2, kasi, because we have 2, this is actually can be expressed as x minus 2 and x minus 2. Or there are two binomials of x minus 2 multiplied to get the result. So these are now the factors, or this could also be considered as the expression for the factors of this. And whenever you have a perfect square trinomial, you would expect a square of a binomial or two binomials of the same expression multiplied by each other. And since we have met this condition, this is the result for the factoring of the given polynomial. The next factor we're looking for is for our next subscriber. Subscribe now!